Hello. In this project, we're going to talk about modulating signals. Signal modulation consists of changing something about a signal, for example, its frequency or amplitude, based on the behavior of a second signal. This technique is commonly used in communication systems. FM radio signals, for example, are frequency modulated. That is, the frequency of the signal is modulated by the amplitude of a second signal. AM radio is amplitude modulated. The amplitude of one signal is modulated by the amplitude of a second signal. We've already seen an example of frequency modulation in our second AWG project when we did sinusoidal sweeps. A sinusoidal sweep is created by frequency modulating the frequency of a sinusoid with a straight line. The frequency of our example sinusoid increased linearly. Our goal in this project will be to get a basic feeling for the idea of frequency modulation. This will come in handy later when we start using modulation to perform some communications-related projects. We'll also learn to use yet another feature of the waveform generator and, as a bonus, make some irritating sounds. In this project, we're going to create sounds by frequency modulating sinusoids. So we should first spend a little time talking about frequency modulation itself in more detail. As I've said already, when we frequency modulate a signal, we change that signal's frequency according to the amplitude of a second signal. The signal whose frequency we're changing is called the carrier wave. We're going to use a sinusoid, like the one shown here, as our carrier wave. We're going to change this signal's frequency based on the amplitude of a second signal, which is called the baseband signal. For example, let's look at using this low-frequency sinusoid as our baseband signal. When our baseband signal's amplitude is high, we want to make our FM signal's frequency high. Alternately, when the baseband signal's amplitude is low, we want to make the FM signal's frequency low. So here's our frequency modulated signal. We have a low frequency when the baseband's amplitude is low, and we have a high frequency when the baseband amplitude is high. We're going to use a speaker to listen to our frequency modulated signals, so our circuit is the same as the second AWG project, the one on sinusoidal sweeps. Again, I'll use a set of speakers plugged into the Analog Discovery headphone jack so that the audio quality of the video is better. Since the circuit creation is the same as the last project, we'll just skip ahead to creating FM signals with the waveform generator. To create frequency and amplitude modulated signals, click on the Advanced tab on the waveform generator. There are three columns to this interface, one for the carrier wave, one to frequency modulate the signal, and one to amplitude modulate the signal. First, let's set up our carrier wave. I'm going to frequency modulate a sinusoid, which has a frequency in the audio range. The top button in this carrier column allows us to choose how to create our signal. A sinusoid is a standard wave, so we'll select that option. Choose sine from the selections below. We want to be able to increase and decrease the frequency and still hear the result, so let's choose 2 kilohertz as our carrier wave frequency. Now let's choose to frequency modulate our signal. As a first case, let's modulate our sine with a square wave. A square wave has only 2 levels, so we should hear a sound that switches back and forth between 2 frequencies. Let's change our frequency fairly slowly, so choose a 2 Hertz frequency for our FM signal. Now the frequency of our sound will be high for 1/4 of a second and low for 1/4 of a second. The pattern will repeat itself twice per second. We don't want to do any amplitude modulation, so I'm going to deselect that option. Click on Run AWG1 to hear the sound. It sounds as we would expect. It alternates between a high and a low frequency. Now let's try modulating our signal with a triangle wave. Now the frequency will increase gradually to its maximum value and then decrease gradually back to its minimum value. Using this tool, it's easy to change the frequencies of the carrier and the FM signal and see what happens.